Hello and welcome to this video. And this video is gonna be about a very important concept which is often talked about, and questions are asked about it in interviews and in discussions everywhere, which is evaluation of GenAI applications. Okay, we learned RAG, okay, we have our agentic system, okay, we have this and that. But how do we monitor them? How do we quantify the performance of our application? That's very important, right? So, for example, if we have a classification model or a regression model in ML, we can quantify its performance and make changes to the model in real time by looking at some scores, right? Like accuracy scores, precision recall, all those things. Maybe R2 score, whatever. So we look at some scores, and based on those scores, we make changes to our model. In the same way, in RAG applications or in any chatbot applications that we can think of, I mean, almost all of them are using RAG nowadays. So, how do we quantify their performance so that we can monitor them correctly? And we can showcase that, okay, our app is performing very well in these areas and not performing well in these areas. So about it. So first of all, as we do it, we start with the intuition. So we evaluate GenAI apps, basically the RAG applications, on the basis of some metrics, just like we do in ML. Okay, and this evaluation helps us majorly in three areas. First is the component selection. In component selection, you can imagine a RAG system has got multiple components, like there is a chunker, there is a retriever, there might be a re-ranker, there might be some scoring mechanism that you are using, similarity search or hybrid search, whatever. So there are multiple components in play. You need to optimize the component selection or the kind of methodology that you're using based on these metrics. Then there is error diagnosis, that if you're not getting good results, then these metrics can help you pinpoint the problem as to which component or which area of your application needs to be improved. And the third part is LLM ops, which is the general monitoring and evaluation and that feedback cycle that we talk about in LLM ops or ML ops, that our application is running, but we need continuous improvement in it, continuous development in it, based on the changing environments and stuff. So LLM ops is another big application that makes use of these metrics. So you can think about these metrics just in the way you think about ML metrics, okay? But there is an issue here, that we know that chatbots generate textual data, right? And it is not very easy to quantify the quality of a textual data. So here I have categorized the metrics into two broad categories, which is first is LLM based metrics and second is non-LLM based. So first, just touching on the non-LLM based metrics. So there are some scores like the blur score or the root score that exist, and these scores have been existing for quite some time, even before LLM was a buzzword in machine translations and all. And these scores basically make use of n-gram matches between the reference text and the generated text. So it is, you can think of it like keyword matching, So it divides the data into a sparse matrix, maybe using TF-IDF, and then going for a keyword matching. If the keyword matching is good, then your blur score will come out to be good. So kind of a mathematical thing is going on over here. You can learn more about these. I've just provided a small description over here, that these are like F1 score of n-gram matches between the reference and the generated text, and suitable for machine translation. But for our chatbot applications, we need something more holistic. We need something that captures the essence of the responses, and what better than an LLM to evaluate those responses. So we have got a lot of LLM based metrics like context precision, recall, entities recall. Not going into this at this point, we'll be looking at this in a while. Okay, cool. So today we are going to use a famous library called the RAGAS library. You can see it here. So the RAGAS library, I'll just go and type over here like RAGAS library. So RAGAS library is a famous library. It's an open source library that is used to evaluate LLM applications. It has got multiple modules and stuff. We'll be covering each of them. Not each of them, but a lot of them, important ones in this video. Okay. So what's the logic? What's the workflow of evaluating a RAG application, say? First of all, we know that, let me just draw it over here. Let me just go more towards the right, okay, towards the open space, open world. So we know that a RAG application, a RAG app, is basically a kind of a framework that uses an LLM, and what it does basically, it takes in a user query and we get a LLM response, or the response, I can call it the LLM response, and there is a vector database involved, right? A vector DB that is feeding the chunks in between, and this is what's happening basically, right? And it is also using an LLM. So basically you can think of RAG in these terms, like it's in a very simple manner, right? So this is what's happening. A user is providing a query and some chunks are being retrieved from the vector DB and everything is put together in a prompt, and then we get the LLM response. Okay. So the first thing that we need to do to start evaluating it, as you know, that we need a labeled data set. If you are familiar with ML concepts, you know that to quantify the performance of any machine learning model, we need to have a labeled data set if you are working with supervised models. Okay. So the same way, we need to have a labeled data set that we call ground truth data set, or the reference data set over here. So the reference data set will look something like, there will be a user query and there will be a LLM response that we got against this using the RAG. There will be a retrieved context that we got from the vector DB, and against every single user query we need to have a ground truth response. Ground truth response is the response which is optimal, or which is the response that we want for this user query. So what we are doing is, we are comparing the LLM response and the retrieved context against the ground truth response that we desire. And we compared all these things, you know, based on multiple LLM based metrics. Cool. So this is the basic workflow. So what we're looking at is a evaluation data set. This evaluation data set, which I talked about, needs to augment some real life situations. Obviously, the kind of questions that we will include in the evaluation data set must be of different abstraction levels that covers all sorts of scenarios that we are expecting the chatbot to be exposed to. Okay. It needs to be obviously clear and high quality. It needs to be of an optimal size. We need to have, you know, various kinds of questions included in it to quantify the performance of our chatbot in all kinds of scenarios. Okay. Now the question arises, who creates this evaluation data set? How do we get these ground truth responses? Now there are two ways of getting it. First is human generated, right? You just sit down and you list, say, 10 to 20 questions that are going to be asked to the chatbot in production environment, and you write the ground truth response, or the response that you think is optimal. So for example, if your chatbot is if it's a travel chatbot, and if a user asks what is the charge for taxi from airport to railway station, okay, if this is a question that you think will be asked to my chatbot once it goes into production, and you want the response to be the fare is between 1000 and 3000 depending on the rush hours. This is the response that you wanted to give, okay? Then basically you plug in this question, you get this truth response, and then you get the LLM response for this and the retrieved context. You compare all of these things to see how your bot is performing. So this is the part, this is the bot part, this is the part that you created, and this is the part that the user provided, okay? In this case, you are only providing it because you are creating the evaluation data set, right? Now this is one step, but as you can see that to cover all sorts of scenarios and to create all sorts of questions using a human guy, it's going to be very time consuming. So what else can you do? You can generate synthetic data, again based on LLMs. You can get the questions and the ground truth responses from the LLM. You provide it with some information and you generate some synthetic data from it, and then on the basis of that data you can validate it, and then you can assign it as your evaluation data set. But that will have its own demerits, because a human intervention is most desirable in creating this evaluation data set, obviously. So as you can see here, evaluation data set can be human created, can be synthetic, and the data set structure that I told you about: the question, answer, context, and ground truth. The ground truth we provide, the question we decide, the answers are the RAG chain generated answers, and the context are the retrieved chunks. Now after this, after creation of the evaluation data set, there is a concept called as singleton sample. I'll tell you about it 2 minutes after this. So we convert these evaluation data set into a set of singleton samples. Singleton samples is basically a class in the RAGAS library, and then we generate the evaluation report, which is basically, we can generate all of these LLM based metrics. Cool. Now let's jump into the code. Cool. So first of all, I have got a certain document over here that is based on RAG again, so that's pretty cool. And I am using the PyPDF loader to load it, and then I loaded it. I chunked it using the recursive character text splitter. And here you can see how each chunk looks like. So each chunk is a LangChain document object, right? Just a second, maybe, yeah, you can see each chunk is a LangChain document object. Then I set up my vector store, and I embed and store all of this in my Chroma vector store. Pretty basic. I initiate the retriever runnable, and then I invoke it. So see, I asked it a question, what is naive RAG? I have set the k parameter to 4. So I'm getting the top 4 relevant ones from different pages, you can see. So these are the chunks that I'm getting for this question. So yeah, our retriever is working. Then I generate the simple prompt for the RAG, which is pretty basic again. And I create a RAG chain. I generate the LLM, I declare the LLM, and then I create the RAG chain. It takes in the context, which is provided by the retriever. The format documents is a simple utility function that is basically parsing or just taking out the page content from each chunk, retrieved chunk, and kind of joining them all so that it gets in a good format to be inserted into the prompt. And then the question is runnable pass-through that I'll provide on the time at the time of invoking this chain. Then prompt, LLM, string output parser, pretty basic LECL. Then I invoke the RAG chain based on the same question, and I get a response. So yeah, the RAG part is working fine, cool. But that's not what we're here for, right? We are here for evaluating it, right? So this is the test set that I've generated over here. I have around 10 questions and 10 answers to them. So this is the ground truth answers and the questions that I expect my RAG bot to answer. Okay. So these questions, I have generated them, okay. And these answers, I have generated them as well. I generated them using ChatGPT, so cool. But in production, I would always, it is recommended that there should be some sort of human intervention in generating these ground truth data set. So I ingest this ground truth data set, but as we know that against each question, as I showed you here, against each question we need to have a AI response, which is a RAG chain generated answer, and the context, so that we can compare all of them. So that's what I'm doing in this block. I read it in a DF, and then I created some new keys. The answer key, for which I'm getting the AI response, and then the context key, for which I'm getting the retrieved context for each single question. So after I got all of this and condensed it into a data set, this is how the data set looks like. So this is my ground truth data set. So this is the pre-processing that you need to do before starting the evaluation using the RAGAS library. So the question, the answer, this is the AI generated answer, RAG chain generated answer, the contexts, and the ground truth that I provided. Cool. Now let's see how RAGAS treats a single turn sample for evaluation. Now what is this single turn? So for RAGAS library, it basically evaluates one single turn sample at one time. So RAGAS library has two concepts called the single turn and the multi-turn samples. Let's see in a jiffy. So single turn sample and a multi-turn sample. Okay. So single turn sample is an object which is used to evaluate normal chatbot responses, and multi-turn sample is an object which is used to evaluate agentic conversations. So single turn sample, as I showed you, it is an object that contains just this part. So this is a single turn sample. A single turn sample contains a user query, an LLM response, retrieved context, and ground truth response. Once I ingest all of this and I create a single turn sample, then I can use this single turn sample and get the metrics out of it. So single turn sample is kind of a class that the RAGAS uses to read the evaluation data set row by row to give us the evaluation metrics. And now what is the multi-turn sample? A multi-turn sample, I'm not touching on this in this video, but multi-turn sample is going to be an evaluation data set for agentic workflows. So for agentic workflows, we know that things are not as linear as this, it might involve some tool calls and stuff. So we can provide all those details in the ground truth in this multi-turn sample. Just to give you a flavor over here, multi-turn sample might look something like query is, say, what is the temperature in Alaska, and then there should be an agent called which is the weather agent, and then there is a tool call, and there is a blah 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 something tool call from the weather API, and then agent response is the temperature is minus 21 degrees centigrade, whatever. Okay, so you see it includes multiple steps, So we can include all of these steps and we will evaluate if our chatbot is following exactly these steps to answer this particular question or not. So that is how the multi-turn sample works, but we are dealing with single turn samples here, in which the structure looks just like this. So yeah, good. This is how the single turn sample looks like. We can initiate it, we can import it over here, and then I created a single turn sample using these values. So it needs a user input, it needs a reference. The reference is basically the ground truth, the retrieved context, and the response, for which I've just invoked the RAG chain over here. And then this is how it looks like. So this is a single turn sample. Now once we have this single turn sample, we can go for the metrics evaluation. So RAGAS supports a lot of metrics. You can check them out over here, list of available metrics. There are a lot of metrics over here. Now they have got multimodal metrics as well for agents, for these are some of the non-LLM based ones, for SQL, for every single thing. In this video, I'm going to show you some important ones which are very relevant for RAG. Okay. So yeah, now is the time that we dive into this. Okay. So these are some of the metrics, LLM based metrics, which are very important to RAG application evaluation. First is context precision. It basically measures how accurately the retrieved context matches the relevant context in the data set. So, a higher value indicates that, okay, the retrieved context, the context which has been retrieved is very close to the relevant context. So both of these, context precision and context recall, these two are aimed at the retrieval efficiency. Context recall tells us out of X amount of relevant chunks, how many were retrieved. So what is the retrieving efficiency? And then there is context entities recall, that in the context retrieved, how many critical entities were retrieved. And then there is noise sensitivity, which basically says how much irrelevant or noisy content was retrieved. Then there is response relevancy, which is how relevant or how well the generated response is answering the query asked by the user. Then there is faithfulness, which is basically the hallucination detector. The good part is, you can stop the video and read through all of this. There's no point in me dictating all of this, but the best part is that all of this are standardized to one particular scale. So 0 is poor match in case of context precision, 0 is there is 0 context recall, or 0 is usually bad, and 1 is basically perfect or very good, not in case of noise sensitivity. That is the exception, and in this case we want a 0 score because we don't want any noise, right? And in faithfulness, as you can see, if the score is 0, it means that the content which has been generated is completely hallucinated, and 1 is well-grounded content. So cool. Now let's see how we can evaluate all of these metrics using our single turn sample that we generated over here. So we use these particular modules from RAGAS. You can install RAGAS and play around with it. So for RAGAS, if you want to use LangChain along with it, then we need to use this LangChain LLM wrapper and embeddings wrapper. Then I imported all of these metrics over here from ragas.metrics. Instantiated the LLM. You can see that I have instantiated it using the LangChain LLM wrapper because RAGAS is not, I can say, inherently integrated to a LangChain like a lot of things are. But maybe in the future we might get a RAGAS module inside LangChain, who knows. Then we create a metrics rubric, or kind of a dictionary, where we are defining every single metric to each key so that it's easy to understand and easy to read basically. And as you can see that each of this metric requires an LLM because these are LLM based metrics. It's gonna use some sort of a prompt in the background to generate the evaluation thing. And you know how it works, right? Um, you know how structured output comes out of an LLM, right? If you don't, just put it in the comment. I can create a video for that. That's a very interesting and very important concept that everyone is vouching for, and it's very critical to Gen AI app development. Okay, so we have all of these metrics in a dictionary now. Then we define a simple function. Evaluate metrics, it takes a sample and the metrics as input. We are going to put all of the metrics in a dictionary called as results. Then this particular method is used to generate a metric.singleton score. Okay, so for metric name, metric and metrics items, we take the results, we add a new key to it, and we take metric.singleton score. So first we calculate the context precision score and append it to the dictionary, and then the next one. So you know how it works, and then we get the results. So you can see the results over here. I have executed it. By the way, RAGAS library evaluation metrics, it takes time, because you can imagine every single metric is basically getting responses out of an LLM and making different calls to it. So it's taking time. Okay, it's like 6 API calls over here. And if you have a lot of singleton samples, you can just multiply it. So you know that you can easily say that, okay, RAGAS library takes some amount of time to evaluate the data set. Okay, so that's why I have it pre-executed, so that we can save on some time. So as we can see that for this particular singleton sample, these are the metrics that we got. So we can see that the context precision is 0.91 something, which means that, as you can see here, just a second. 0.91, a higher value indicates that the retrieved context closely aligns with the relevant context, suggesting accurate retrieval. So the context precision was quite good. Context recall was 1.0, which means that all of the relevant context was retrieved successfully. So that's good. And then we can see that context entities recall is low. It means that we missed out, or our retrieved context was missing out on some critical entities that we should have retrieved. And we can see that noise sensitivity is 0.55, which basically means that we had quite an amount of irrelevant content retrieved. Response relevancy is 0.95. It is basically like the most important metric. It basically says that the question was kind of answered by our chatbot anyways. Okay. Faithfulness was 1.0. It means that there was no hallucination. Cool. Now, I showed you this entire data set. You might have a data set like this when you're working with some kind of chatbot development. What you need to do is, we need to convert each of this row that I showed you in this data frame into a singleton sample. So each of this row will be converted to a singleton sample, and then we evaluate the metrics for each of this singleton sample, and then maybe append that to a data frame for visualization or whatever. So that's what I did over here. So I defined a function evaluate row, which basically takes in a row as an input and converts that row into a singleton sample. Then I have the evaluate data frame, which basically calls on this particular evaluate row on each row of it and appends that to a data frame. So you can just look at this simple like pandas coding and shit. So I evaluated it, and again, disclaimer, it takes some amount of time to run, and this is how the evaluation data frame looks. So each row is an evaluation run on a singleton sample that we got from the evaluation data set, and you can see the values in a very clean format over here. So like context precision is 0.91, 1.0, and things are looking okay. If you want to track this thing, you don't want this particular metric to go down, because it would mean that your chatbot is not answering the questions properly. So you can just monitor all of that in one particular screen. Imagine that in your chatbot, that you can monitor all of these values in real time and understand the performance of your chatbot with every single query maybe. So you don't want to do this with every single query, but maybe once in a while, just like we do it in MLOps. So for example, as you can see here, for the third question, the context precision was quite low, 0.5, which means that half of the chunks retrieved were irrelevant, which means that we need to improve our retrieval mechanism. So that's how you do component selection. You can see that there was a lot of noise produced in this case. So the amount of irrelevant content was literally very, very high for this particular question. So you can literally monitor that the RAG framework's performance is varying quite heavily by the different case scenarios for different questions, which particular things your RAG bot is good at and which particular topics is it struggling with. You can easily pinpoint that and you can work on improvement and everything. Okay, so yeah, this was kind of it. And if you want to generate the synthetic dataset, you can use this test set generator module. I don't know, it was not running for me. Maybe there was some issue or some kind of servicing going on in the RAGAS library, so this was not quite loading. But yeah, you can try this out. I will be attaching this particular notebook in the video. But anyways, you can also generate this particular synthetic dataset by yourself by using OpenAI, or good ChatGPT, get it from there, or just write a prompt yourself, because test set generation is something which is very, very domain specific, right? And as an chatbot developer, you are the one most aware of it. So yeah, so this was it, guys. This is a very important concept, and flaunt this knowledge in interviews. I mean, people love it. People love to hear about evaluation. I mean, development is good, but without evaluation, it's all shit, right? So yeah, I hope you learned something interesting today, and stay tuned. Bye-bye.